On a busy metropolitan rail network approaching the peak travelling period, two suburban passenger services are stopped at separate stations, seen here as Train 1 and Train 2. On the section of line between the two stations and the trains are three signals, A, B and C, and a crossover point that facilitates movements between the two lines. Train 1 allows commuters on and off, and while stationary, signal A displays a flashing single yellow aspect to warn the driver of the crossover point on the section of line ahead. At this point, Train 2 leaves the station and travels towards the crossover point. Seconds later, Train 1 also departs. Just 15 seconds elapse before the two trains pass each other as Train 1 approaches signal B, which is displaying a red aspect, requiring the train to stop. Train 1 passes the red signal B and continues past the required stop toward the crossover point. Network control is alerted by a signal passed at danger or SPAD alarm and places an emergency call to the driver of Train 1. While the call is acknowledged, the driver doesn't bring the service to a stop until it is more than 180 metres past the red light at signal B. While a tragic incident was averted in this case, the reality is there was potential for a head-on collision. In fact, had Train 2 departed the station between just 12 and 15 seconds later than it did, it is possible it would have collided with Train 1. Subsequent investigations revealed that the driver of Train 1 had become distracted at a critical time while stopped at the station and failed to take heed of the flashing yellow at signal A. Having passed the red light at signal B, Train 1 did not immediately come to a stop. Rather, it continued dangerously towards the potential conflict point at the crossover. Of most concern to ONRSR was the less than optimal effectiveness of the range of mitigating controls that should have alerted the apparently unaware driver that the red signal had been passed and seen Train 1 stop well before the potential conflict point. As a result, all existing risk assessments and controls had to be thoroughly reviewed and recast, while additional controls that could be applied, so far as it is reasonably practicable to prevent a similar incident, were identified. The general safety and SPAD risk at all other locations on the network where similar risks existed were also reviewed, and additional driver training material was developed with a focus on dangers of distraction. ONRSR expects absolute vigilance in the control of SPAD risk because instances of trains exceeding the limit of their authorised movement are considered important precursors to collisions and derailments. Possible controls to consider when addressing the safety risk posed by SPADS include, but should not be limited to, interlocking, signal overlap length, SPAD alarms, procedures regarding the speed of trains in particular circumstances, such as where limited sight distances exist, automatic train protection. Operators should review how SPAD risk is being addressed through safety management systems and reassess the effectiveness of all mitigating controls, including addressing with drivers the importance of maintaining concentration at all times. Operators are asked to pay particular attention to those SPADs that have the potential to see trains overrun into conflict points and cause catastrophic collisions. In the last financial year alone, there were more than 450 SPADs on the Australian network, more than one every day.